and give you a brief overview on the topics I will supervise of master thesis, together with some colleagues, of course, but just to give you a general idea, and maybe also talk about the classes and modules which would be appropriate to attend if you're interested in these topics. So this doesn't work. So this is the first overview. I mainly work with drought risk assessment and management, which includes, on the one hand, the drought hazard, which is climatic and hydrological hazard of lack of moisture from the climate, and also the human influences on abstractions of water. So hydrological and meteorological drought hazards, and also the management. So how can I deal with lack of water and water scarcity? So as this has a human component as well, it is quite interdisciplinary. No? So on the one hand, you look at the natural conditions in a catchment and the climate, and on the other hand, you have the humans who use the water, of course, and also lead to water scarcity. And sometimes you have to differentiate between, is this now human-induced drought? So is it because of overexploitation of water and freshwater resources, or is it due to real climatic phenomenon, only a lack of moisture in the system, which is unusual, no? And an anomaly. And so once we have assessed this drought and found also the reasons for it, and understand the risk, which is composed of human and climatic influences, we look at nature-based solutions. No? How can we address droughts in a catchment depending on the individual settings of this catchment with nature-based solutions for adaptation. No? So this means, again, we have to look at the catchment, the characteristics, and then which typical nature-based solutions related to infrastructure, green infrastructure or semi-green infrastructure, and as well agricultural uses, no, which need to adapt also to drought conditions. So there's different types of adaptation measures, based nature-based adaptation measures. And the third topic is the water, food, energy security nexus. Some of you were in this module in the last winter semester, and then you actually know what I'm talking about. For the others, I warmly recommend you to attend it in the next winter semester. And it is about first qualitatively understanding a system, a nexus system. Then, or you can also choose one or the other, quantitative assessment of a system, or only two-component relationship between e.g. water and energy, or food and energy, or land and energy, and then find, based on this quantitative assessment and the knowledge we have about the system, governance solutions to solve this problem. No? So if you haven't identified trade-offs and synergies, you can maybe, based on the potential synergies you can find in the system, find solutions also of dialogues and governance. And in the last, this is more technical, so it's about hydrological modeling and data scarce tropical and semi-arid and snowmelt-driven systems. I will talk about that more later. So my regional focus, or of many of my colleagues, but I actually only work there, is Latin America. So we have many partners and case studies in Latin America, and Southeast Asia as well, especially Vietnam. And yeah, you all know this figure from last Ribbe. So the main regions I've been working is here in Chile, Limarí, and many other catchments, the Paraíba do Sul in Brazil, Magdalena, Machangara in Ecuador, Magdalena is Colombia, and here we also have Costa Rica, the Tempisque Basin. then what would be very interesting is, of course, any snow melt-driven system with similar characteristics as the Andean region would be the Indus Basin, for example. Also supplying water to large irrigation systems and the whole Southeast Asian region, the Mekong, but also the neighboring regions with rice irrigation and over-exploitation of freshwater resources, where we have been working for almost 15 years now. So this is, for example, a university cooperation project where we offer scholarships for field research, and of course you also would be embedded in a context of researches and projects, which is the Topiseca project. Here we work with the Universidad de Cuenca in Ecuador, the University of Costa Rica, where we are currently building up a master program as well, and the University Javeriana in Colombia with a Master of Hydrosistemas. And well, we could jointly work together on the case studies I just showed in Central America on hydrological meteorological drought assessment, and also try to involve stakeholders, informing them about droughts, because this has not been a problem in the past, and now, of course, the water management and the governance is not adapted to this. So it's very important also to have this dialogue and to inform them about the risk, especially where you don't have reservoirs and storage, and you just cannot do anything if there's a long period without rainfall. Another project we are working in is the Adapter project. This is the Paraíba do Sul basin in southeastern Brazil, also tropical, and yes, it's also about assessment of drought, or my role is assessment of drought and drought adaptation. So here we have lots of data, lots of problems, lots of possibilities to work in. So these are just examples. Of course, this can be applied to any other region. And here is, again, to repeat this, for example, in the Paraíba do Sul, but also in some other regions, we have all the data available and have also done first studies. So the task would be more to go into detail and to look at sub-catchments with the same topic. So here we look at meteorological and hydrological drought characterization, which is mainly looking at past time series of discharge, temperature, and mainly precipitation, and see where you can find a drought signal and try to find also patterns, for example, related to the ENSO phenomenon. And then hydrological modeling, this can be more oriented towards the natural system. So would, for example, a land use change have for an impact on low flow? No? So is there more water downstream if you have a big forest, or after deforestation? How would that impact on the water availability? And we also have already modeled, and we have several models available, but further interpretation and evaluation of the results would be really nice. And then we always are in data scarce regions, so the hydrometeorological time series usually are full of gaps or not existent, and there are also other data missing. Of course, impacts and abstractions from humans is almost impossible to obtain, but what we are trying is to compensate this lack of data all the time with satellite-based information. So we have plenty of papers about how to use satellite-based precipitation products, which is the best one for a tropical region or for this region or mountainous region or a coastal region, and then use it for hydrological modeling. No? And we have very good experiences with that usually they work better than the measured data. And in the context of droughts, we use these hydrological models to determine drought threshold indicators. So we calculate which is the minimum flow based on the past hydrological time series and the simulated time series maybe also in the future. And the human impact, until now we have mainly worked with hydropower reservoirs or other reservoirs and how these influence, how these alterations of the hydrological system influence the water availability. So hydropower usually changes, or it takes away water from high flows, or it adds water to low flows, and so it can help, but it can also have negative impacts on the discharge. But we have to assess this in a seasonal, on a seasonal scale. So we need to know each month, is there a lack of water, or after the building the reservoir or before, and how this could be optimized. So we have worked with several models about how reservoir operation impacts on low flows. Because in research, most of the hydrological studies are concentrating on floods. It's not really, of course, low flow modeling is nothing new, but still it's not, especially in tropical region, it's not sufficiently addressed or has not been used. So a model calibrated towards low flow modeling is not the same as a model which concentrates on the peak flows, and therefore, we need certain calibration and evaluation techniques to do so. So there's a large, where my colleagues, we are all working together on this research, and we would be really happy if we would have students to join us. Again, this is what I said in the beginning. This is more interdisciplinary, not so much concentrated on modeling. So we have, on the one hand, we have the natural system, which is usually modeled, and on the other hand, we have the human component, which is actually more important. We can say that the human abstractions are more, or usually are the reasons for drought, or more have more responsibility in the development of droughts than only climate or the lack of rain. So what we need to identify are the impacts of droughts. No? So we assess a past drought, then we go to the field, or we ask the institutions in that region, how would you describe the sectors, or which were the sectors which were most impacted by droughts? No? So for example, the hydropower sector or the agriculture sector, specific crops, or the public water supply system. So there's a variety of the possible impacts of droughts or forest fires or other vegetation-related problems. So what we need to find out is which were the problems related to that, and also use them as an indicator. No? Or then if you develop a drought risk map, for example, then you can say, well, where do I have the biggest risk? For example, where the population density is very high, or where the crop density is very high, or where where there's no infrastructure nearby for water supply or reservoir or something like that. So there are several ways how to define this risk of the impact side, and also then investigate if there have been impacts in these on these sectors. Yes, and then of course what is most important actually, but always a lot of investigation is needed to do so, is to find responses for that. You know? To define a strategy, how we can overcome these problems, and how could we avoid the next drought disaster, no? Because that many components related to that. So again, what we work, these are social sciences related methodologies which we need to apply, and on the other hand, we can use water allocation models and look how the different operation of water resources in the basin, and abstractions would impact on the downstream flow. And based on these quantitative analyses, then take decisions, no? Which sectors have to be protected and how we can allocate the water in a way that such drought disasters are prevented, are avoided. So now I would just so that you can imagine what we're doing. Joschka, for example, he's also working in this project or in this research, is that well, we have been working in the Andes now for 20 years on different studies, especially hydrological modeling. And as you can see here, this is a wet year, a wet winter, where you have a lot of snow cover. And this is a dry year. No? So you can imagine how important the snow is. So in the summertime or in the spring, when the snow melt starts, all these valleys here in these catchments are supplied with water from the mountains for irrigation. No? So this is in springtime, in summer, and so this means that on the one hand, this is a completely different way how to model than in a tropical region, or how to analyze also the drought risk and the seasonality. And on the other hand, the vulnerability to climate change is very high, no? Because it is there have been trends in the last 30 years that the temperature is rising, especially at the higher elevations. And if this trend continues, then it's very likely that the water availability and the seasonality will totally change. No? So there is a lot of research demand on developing scenarios on how would the future water availability in springtime and summer look like, depending on future precipitation and temperature rates in the Andean Cordillera or any other mountain range, no? Because this trend is not only existent in the Andes, but also in any, I can give you the papers, in any mountainous area worldwide. So what we do is work on these scenarios, and also here again, this is a very data scarce regions. The mountains range up to 6,000 meters, and we need to substitute the precipitation values, because as you can see in the winter, I mean all the rain actually is falling here, and down there there's much less moisture and much less precipitation. So we need to estimate how much precipitation falls in during the winter time, and this for every year. So this would give us the possibility also to calculate short-term predictions for water availability in the spring and summertime. Just to show you how this looks like more or less. So this is almost late spring, almost no snow there. If you have winter, it's everything covered with snow. And the streams are relatively small and everything, but very fast. So the runoff is much more, due to the slope, higher than it looks like. And now for the specific case of Chile, we would also offer a master thesis or several looking at the geochemical values in high elevation streams to assess residence times and also the behavior of spring and meltwater during the melting season to inform hydrological modeling. So we have done previous studies, and now we identified several other monitoring needs or any sampling strategies to understand this. So we use stable isotopes as and also normal hydrochemical parameters to assess the behavior.